Okay, so why do we learn organic chemistry? Some of you think, well, my degree requires it. Well, they kind of sad you said that, but hey, there's much more into it. The reason that we learn chemistry or organic chemistry in general is really your life. This is how we explain things, right? With either be food that you eat, medicine that you take, how we function as a human, how do we think, how do we move, even the like everything around you. There's chemistry, especially organic chemistry. Organic chemistry talk about our body, basically anything organic. Right? Have carbon and hydrogen, and we basically our body is totally carbon and hydrogen. Drugs, the food these days are mostly are organic compounds. Okay, and we use organic chemistry to explain things. All right, so I'll give you some uh, kind of related to our life, but we're probably not related to you yet. Okay, because we're gonna talk about this guy, anti-cancer drug. I hope none of you have to use it. Okay. Anyway, so I don't think most of you have heard this anti-cancer drug before called cyclophosphamide. Look like this. So we got two arms, we got and a body. Okay. And its function to kill cancer somehow. We talk about this guy more in detail in chapter 4. Okay. All right. We're going to start it right here. So it go back a little bit in early 2010s. I'm sure you have heard or maybe have watched. I mean, some of you have read it, the Hunger Games. All right. This one we're going to go to the movie 2 or book 2. Catching Fire, where Kenneth Evidence, played by Jennifer Lawrence, right? So they go to kill each other in the clock arena. Okay, one of the arenas. So it got that toxic gas, if you still remember, and Kenneth Evidence reaches out her hand, come to contact with that gas, and if anyone remember what happened to her hand? Well, her hand got blistered or chemical burn. Okay, and we for us, we think, oh, that's toxic gas, don't touch it. That's a new thing. But actually, no, this toxic gas has been used for a long time ago in World War One. Look like that, called sulfur mustard. Okay, we have sulfur, we have 2-chlorine on it. And there are a few smart people think, well, if sulfur mustard really toxic to human body or anything that come into contact with, what if we use that to kill cancer? Right? In 1931, sulfur mustard showed anti-tumor effect in human. I have no idea how they tested. I don't want to know. Okay. But it's too toxic for our body. So we have two professors, Dr. Alfred Gilman and Louis Goodman. They are professors at the time at Yale University. So they find analog of sulfur mustard or something that looks similar but less cytotoxic effect or less toxic to our body called mechlorethamine. Look like that. We call it nitrogen mustard. Okay, and this guy actually showed the anti-tumor effect and extend life in animal experiment animal. Look like a rat or a rabbit. All right, that's in 1942. So during the World War II. A year later, well, we got this guy that can kill cancer. So they put that onto a human. And that's really unethical, but wait, that's during the World War II and it's old time. I don't know how that works, okay, but we don't do that anymore. The first clinical trial happened in 1943. This patient is in the last stage of lymphosarcoma, which is a cancer in the neck. Of the patient, right? But his last stage, he's dying. So no choice. Why not try the new medicine, new drug, right? So he got treated. So this chemotherapy got treated with mechlorethamine, and surprisingly, the cancer on his neck becomes smaller. Okay, so this guy actually show effect, have potency, have some selectivity, but not enough. Unfortunately, later, first of all, they don't know how much mechlorethamine have to treat the patient. They apparently they added about 20 or 30 times more than recommended dose nowadays. Okay, that's way too much. But they didn't know. They just experiment. All right, and eventually the patient relapsed and died. Okay, but this showed the first time that hey, we have an anti-cancer agent and we can develop this for to be have a better potency and better selectivity to the cancer cell over the normal cell. Okay, before we go further, so a little bit the history. this project is so secret that these two wrote on their note. They didn't call this compound microrhythmine. That's what we call it nowadays. But back in the day, they just called it compound X. They wrote in their lab notebook in the experiment called compound X. It's really secret, just in case someone steal their work. Okay, but it's so secret that so it's called compound X. And here's what I think about it. This compound is called compound X, and the patient died. What if the patient actually didn't die? He got treated and he became an X-Men. I don't know. I'm just thinking. That's just a funny thought. Okay, but I don't think that's true. But maybe. Who knows? Anyway, go further. So in 1950s, about 10 years later, the cyclophosphamide was synthesized, and it showed the anti-tumor, anti-cancer effect, right? How they work, they cross-link the DNA, so DNA cannot do their function. We'll talk about it in chapter 4, okay? And later, so cyclophosphamide was developed even further, and you can see analogs of cyclophosphamide. We have ifosfamide, got two arms still, but different position, right? We have glufosinamide. If you, some of you know this is glucose unit attached, phosphoramide mustard on the glucose. The idea of this compound is so the cancer cell is like it's a fast growing cell. Think about like a baby growing, right? They eat a lot, they sleep a lot. Cancer just like that, eat much more than a regular cell. Okay, and so we attach the glucose into the phosphoramide mustard. So it's like we give a candy to cancer and go, hey, this is candy, take it. There's a bomb inside, but we don't tell them, right? So cancer is going to take up this glucose and think about, oh, this is glucose, let's eat up. But it got phosphoramide mustard on it, and that's killed cancer as it improves selectivity. We have trofosfamide. There's a 3 arms, okay, but with better potency than cyclophosphamide. And the development is shooting for better anti-cancer drug. What do you mean by better? So higher potency and less side effect. Okay, it lasts longer in your body. If it lasts longer, we don't need to add a lot of dose. If a medicine doesn't last long, we have to add more and more, and that's lead to more side effects that we don't want. Okay, drug-resistant cancer is one of the what's called greatest disease in terms of being resisted. Okay, resist any kind of chemotherapy. So the chemotherapy normally we just treat with a different medicine, different anti-cancer medicines. Okay, so to prevent drug resistance. And the last one, the hardest one to overcome, selectivity of to cancer cell over the normal cell. This compound or this drug can kill cancer, but cancer is just a regular cell that mutates. Right, the normal cell, it's not mutated. It's a normal cell. So anything that kills cancer cell can also kill a normal cell. If you know that any cancer therapy patient that lost their hair, that lost their nail, those are fast growing cell. Anything fast growing cell got destroyed by this medicine. Okay, the selectivity to cancer cell is the hardest, the most difficult part of we call medicinal chemistry in terms of finding an anti-cancer agent. All right. So what are we going to learn in this course? So you're going to learn the molecular structure, how to draw it, what does it look like, all right? And I'll talk about naming and functional group. This for our communication. When I call, okay, this is compound. The name of this compound, you know, oh, what I'm talking about. This is for communication. And then we're going to go to how does it work, the reactivity. And that will allow us to synthesize or know how to cook them. Okay, what can react with what cannot react with what. Right? For example, we have nitrogen mustard can react with POCl3. Put this unit onto the nitrogen mustard, look like that. All right, and then attach 3-amino propanol, look like that, onto this compound, so we get cyclophosphamide. Okay, and lastly, we're gonna learn about application throughout the course. So how does things work to explain it? Okay, using all this organic chemistry stuff, it's gonna be interesting. And I told you we're gonna have a fantastic time. Trust me, okay? All right, let's get started with the first video for chapter 1.